video is on chapter 17 on probability, lesson number 1, fundamental counting principle, and permutations and combinations. For your fundamental counting principle, it says here that if decision M can be made M ways and decision N can be made N ways, then the two decisions can be made M times N ways. So we're going to use multiplication here to find out all possible outcomes. For example, number 1, it says the ice cream shop offers a choice of 3 cone sizes, 15 flavors, and 8 toppings. How many cones are possible if you can only choose 1 flavor and 1 topping? So your fundamental counting principle is applied here. Since there are 3 different cone sizes and 15 flavors and 8 toppings, you're just going to multiply all those things together, and that gives you 360 possible outcomes for the different ice cream cones you could create. On example number 2, it says Virginia license plates consist of 3 letters followed by 4 digits. How many different license plates are possible? So your alphabet has 26 letters in it, and when it talks about digits, you have to include 0. So there are 10 digits. 1-digit numbers is what we're focusing on there. So 3 letters, so that would be 26 times 26 times 26, and then 4 digits, so 10 times 10 times 10 times 10. Now obviously we could write this 26 to the 3rd power times 10 to the 4th power. That would be a different way of writing that, but you're going to get 175,760,000 different license plates that can be created using that particular combination of letters and digits. Let me do one more in this section. Let's look at number 4. To enter their home, the Clayton family enters a 4-digit code. How many codes are possible? So you can look at that as 10 times 10 times 10 times 10, or 10 to the 4th power, which is going to give us 10,000 different variations for that code. The next section is called factorial. Factorial is the product of all natural numbers from n to 1. The example that I have here is 9 factorial, which becomes 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1, which if you put all that in the calculator, you get 362,800. The thing is, we don't want to have to continuously type in each one of those numbers and multiply. Your calculator will do that for you. So in the calculator, alpha window, once it pops up here, alpha window, I'm pretty sure is where we need to go. Yeah, alpha window down here at the bottom. Number 7, number 8, and number 9 are the statistical parts of this particular menu. Factorial is number 9. So what we're going to do is we are going to put in our 9 alpha window, select number 9. There's your exclamation point for the factorial, and it's going to pop out the answer, 362,800. If you've got one like this fraction, this 17 factorial divided by 11 factorial, again, the calculator is going to do all of that for you. Just pull up a fraction, 17, alpha window, number 9, arrow down to the bottom, 11, alpha window, number 9, and the calculator is going to give us the answer of 8,910,720. The last one is interesting. It's 0 factorial. So if I put in 0 and pull up my factorial, it's going to tell you that 0 factorial is 1. Moving on to permutations. So permutations are an arrangement or lineup of objects in which order matters. And there's a great formula here. It's got n factorial divided by n minus r factorial. You don't even have to memorize that. because the calculator is going to do that for us. It is important that you know what the N and the R stand for. So the N represents the total number of objects available. So how many I'm picking from. And R is the number of objects to use for the arrangement. Again, N, and this, the permutation of N objects choosing R is how we say that. And the calculator is going to do all that for you. But you have to know the N is the total number of objects that are available to choose from, and R is the number of objects that you're going to choose or you're going to arrange. There is an important shortcut here. When the number of objects that are available matches the number of objects that you are going to arrange, it's the same as n factorial. So let's look at example number 5. Example number 5 says, how many ways can you arrange the letters in the word dinosaur? So if I were going to take each one of those letters and choose a letter for the first spot, the second spot, the third spot, the fourth spot, and so on, it's going to be a permutation because we're putting things in a specific order. And in the word dinosaur, there's 8 letters. So I'm choosing from 8 letters, and I'm going to use 8 letters. So because the number of objects I'm picking from matches the number of objects I'm picking, that would be the same as 8 factorial. But let me show you in the calculator. Alpha window. Permutations are number 7 on this menu. I'm going to go ahead and choose number 7. And then you would just put in the 8. And the 8 and the calculator will tell you there's 40,320 ways that we can arrange all of those letters in the word dinosaur. Number 6 says 7 students are competing in a geography bee. How many ways can they finish in first, second, and third place? So again, we are picking for specific spots: first place, second place, and third place. So that's what tells me this is a permutation. Because remember that in a permutation, order matters. So permutation, I've got 7 students, and I'm only going to choose 3. 1 for first place, 1 for second place, 1 for third place. I'm going to go to my calculator, alpha window, select number 7. Again, we're choosing from 7, and we're picking 3. So that gives me a total of 210 ways that can happen. Let's look at one more in this section. Let's look at number 9. There are 28 students in Mr. Miller's homeroom. How many ways can the students elect a student council representative and alternate? So he's got 28 students, and he's going to select 2. 1 for student council representative and an alternate. Y'all, again, this is a permutation because he's selecting for specific things. The order in which he chooses, you're selecting a representative and an alternate. So I've got a permutation of 28 students, and I'm selecting 2. Again, you would put that in your calculator, and your answer is going to give you, calculator's going to tell you it's 756 ways that can happen. In this next section is labeled permutations with repetition. So when we talk about permutations with repetition, you've got to divide the permutation by the factorial of the number of objects that are identical. So in number 10, how many different 10-letter arrangements are possible using the letters in the word automobile? In the word automobile, you've got O's that repeat themselves. There are 10 letters in the word automobile. So we would have 10 factorial, and we're going to divide out anything that repeats itself. So because the O's repeat themselves, and there's 2 of them, you're going to divide by 2 factorial. Again, stick that in the calculator, and you're going to get 1,814,400. Now, if you have more letters in your word that are repeating, you have to multiply those in the denominator. But again, they're in the denominator, so they would be divided out. Number 11, how many different 9-letter arrangements are possible using the letters in the word disappear? So in the word disappear, we have 2 P's, we have 2 A's. And so there are 9 letters in that word. So the numerator is your 9 factorial. And we are going to divide out for the A's and the P's. And you multiply those together in the denominator. Again, you're just going to stick that in a calculator, and it's going to tell you that there's 90,720 different ways that can happen. The last thing in this notes is something called combination. So a combination is a group of objects in which order doesn't matter. Order doesn't matter. Again, there's a formula for this, but the calculator is going to do that for us. You do have to know that N and R here represent the same thing as in a permutation. N is the total number of objects that are available. R is the number of objects to use for the arrangement. An important shortcut here is the combination of N objects. Choosing N is equal to 1. So in our examples, Natalie has 16 close friends. How many ways can she choose 5 to be bridesmaids in her wedding? So because it just simply says she's choosing 5 bridesmaids, she's not selecting a maid of honor, a matron of honor, any of that. Order here does not matter. She's just picking 5 from the 16. So this is a combination. Again, there are 16, and then she's choosing 5. So the N is the number that you're choosing from. That's the total, which is the 16. 5 is the number that she's choosing. So I'm going to go to my calculator, alpha window again, and we're going to select number 8 this time for a combination. And again, got 16 friends, and she's picking 5. She's choosing 5 for a total of 4,368. Let's do another one more here. Abby is number 14. Abby is adopting kittens from the pet store. If there are 15 kittens, how many ways can she choose 2? Again, order is not going to matter here. It is a combination, and there are 18, and she's choosing 2. And when you stick that in the calculator, it's going to tell you that there are 153 ways that could happen. So read through each of these scenarios. Again, try to think about why each one would be a combination and not a permutation. Remember that in permutations, the order in which you are selecting the way you're putting things together matters. And in a combination, order does not matter. So there's your video on fundamental counting principle and permutations and combinations.